So I have basically skipped some part of the video and completed the code. So now I am going to explain the code from this point. So we'll go from the very beginning. How the code is going to start? The code is basically going to start from the main function. Okay, when coming in the main function, it is going to call the R main user init function. So in the R main user init function is present over here only. The first function that is automatically written over here is EI. EI basically stands for enable interrupts. So prior to this, if interrupts were disabled, so this is the point after which the interrupts are going to be enabled. So if there is any portion of code that you do not want to repeat, that should not be present in the while one code, and prior to that, if you wish to write anything, you can write that portion of the code over here as well. So you need to understand your code, or the statements that you are writing, they needs to be written before EI enabling interrupts or after enabling interrupts. So that is the option or basically the decision that the firmware engineer has to take up. Okay. In my case, we do not have anything to write over here, so we'll just be proceeding. So once the program comes out of this function, it goes over here to while one. Okay, what is going to happen in while one? I am going to turn on the LED, or you can say I am going to give a high signal on pin number 3 of port number 6. This will be high, one is high. Okay, afterwards I have created one function that is basically going to give me a delay of 1000 milliseconds. ms I have written for milliseconds. Okay, so how this function is going to work is now I am going to explain. Okay, this is the function, this is the definition of the function. Right, when this function is there, the first variable that is there is the count variable. Okay, and the value of 1000 is present over here in the delay time. So the 1000 becomes delay time. Okay, count I have done, I have reinitialized to 0, and I am afterwards I am basically starting my timer. So as you already know, I have explained previously that once the timer is started, it is going to give me an interrupt after an interval of 1 milliseconds. So what is going to happen, how this interrupt is going to come? Once 1 millisecond time is crossed up, it is basically going inside a interrupt ISR. The interrupt ISR are basically written in the user.c files. Okay, so each peripheral will have 3 files. One is timer.c, one is timer user.c, and one is timer.h. So these other .c and .h file, they are basically having the functions that you need to call, or at times the options that we have selected in the GUI. Those options are basically created inside of functions which are present in these two files. Okay, so our motive for where the ISR functions will be written are basically present in the timer user.c. Okay, so in the timer user.c, as we can see, this is the interrupt function, this is the ISR. So what I have done over here, I am basically incrementing the count variable. Okay, so as you have seen in my delay.ms function, when this delay function was called, the count variable was initialized from 0. Okay, and as 1 millisecond get passed, so this interrupt is going to come up. Right, after a period of 1 milliseconds, I'll increase this value. Okay, so after 1 millisecond it becomes 1, then 1 more milliseconds passes up. The code will remain stuck over here in the while one loop. It is in the there's a NOP statement, and it will remain in while one, because as the count value will remain lesser than the delay value. The delay value was 1000, which I have written, and the count value is getting incremented starting from 0. So it will become 1, 2, 3, 4, 5, 6, because the timer we have once started, it will remain on until and unless we ask it to stop, and after every interval of